My name is Amir, and everything that I'm going to be presenting here either is in it's in this slides or it's on GitHub, and the link it's just down there. As you can tell from my accent and talking slowly, I'm not a native English speaker, so I'm trying to cut down on running time on the codes and that kind of stuff to fit it in that 45 minutes. I worked at a embedded Linux shop as an embedded Linux developer. In some of the presentations today, I was the type of guy that was referred to as no shoes t-shirt and dark corner, writing kernel patches and complaining all the time about that administrator that doesn't give me access to the production environment. And after that, I started in a relatively small ISP, a rather big telecom company, in a bank, and last but not least, Radialpoint. You see the logo of at the bottom left, which is acquired by AppDirect a few months ago. So I transitioned to my current, let's say, DevOps position, for lack of better name, through all kinds of roles: OSS, IN, system admin, NOC. Currently, I'm part of a operations team, but 90% of the time we are developing stuff, we are writing code. Something's never changed. I've been lazy since the beginning, and as one of my colleagues likes to put it, I'm lazy and I'm proud, because laziness is just a derogatory word for working optimally. In Radialpoint, we have been through lots of data centers. At some point, around 2012, if I'm not mistaken, we had to manage 5 different data centers at the same time. And we had to switch between data centers a lot. Something that does not change, something that has never changed, and we are not planning to change it in this Radialpoint, is a change. Like, we're sure that something is going to change relatively soon in a relatively significant way, including changing data centers. At the beginning, softwares were deployed using source control. It was not Git at the time, like CVS or SVN, checking out directly on the production machines. It's funny, but it's scary. Then people started creating artifacts like tarballs. It's better than creating packages. Then using CF Engine to deploy those packages and managing machines, and developers hated that, and it never got into, like, it didn't get into the state of developers committing the, let's say, states or state files that are deploying their application to the operations team. It was always operations team pushing for automating those applications that we wanted to deploy. The Radialpoint, part of AppDirect, the company that was acquired by AppDirect, is relatively small, like somewhere around 80 employees. We're reaching 100 shortly. We're hiring aggressively, constantly evolving. Currently, we have 2 DCs, and the hardware in those data centers are really old, like 6 years old. So we need to either replace those or use some cloud services. So, as like everyone can guess, we are going to use cloud services. One of the biggest players in that market is Amazon. We had some experience with that because we did our DR in Amazon. It's really easy and cheap because We can have a few machines, including the Salt Master, and everything else, we just spin up machines in case of a real disaster, so it's really cheap. We don't need to have a clone, an exact copy of prod running always and paying for it just for the DR that we hope that never comes. And we have somewhere around 400 services. A lot of them are legacy. As you saw in one of the previous slides, we did a lot of migrations. And in every migration, we needed to create an infrastructure. Now what we do is, for infrastructure, we are using SaltStack because we have Blaze, it abstracts the hardware. We have virtual machines, and on top of that, we have installed SaltStack, and we started using AWS for DR. So we have both. Unfortunately, Salt supports more than just those two seamlessly. And that moving was a week ago, 3 weeks ago. We moved development environments to AWS, and the prod environment is going to be moved end of this month. In order to provision that, in order to do all the provisioning and create the infrastructure, we are using CloudFormation and Terraform. The reason that we are using both is InfoSec started with CloudFormation, and it's an independent, small but powerful entity in the company, so we couldn't force them to consolidate all those all those code that they had for IAM and role management and stuff with the rest. So the rest of companies using Terraform for all the infrastructure. That's just infrastructure, like subnets and routes. For everything else, we use Salt. We have somewhere around 230 states, and by everything else, I really mean everything else. We provision machines by Salt Cloud. We configure them by Salt Cloud. By Salt, sorry. We monitor them using Nagios with a front end that's called Adagios with Salt. Performance metrics are gathered by Graphite and presented by Grafana. Logs are aggregated by an L stack, which doesn't have the L, which is Logstash, Elasticsearch, and Kibana. And everything is configured by Salt. But we have a few exceptions. Like for databases, the database doesn't mean anything without the data. So we can create a database machine, we can configure it, but it doesn't have the data. We need to replicate the data. We don't do that using Salt. We can. I have something written on my blog that does it via Salt, the replication thing. But the problem is you need to transfer gigabytes or terabytes or petabytes of data through the Salt channel to do the replication, which is not a good thing. Actually, it's not just that. We also have DNS. And that internal DNS is a bit different. It's one of those animals that are a bit more equal. Why an internal DNS? This Building Microservices book, I didn't know about that book until a week ago. One of my colleagues in the engineering team showed me that chapter about microservices at scale. And the first thing that was mentioned in that book was start simple. It's nice to start simple with a DNS to scale out. No one wants to memorize IP addresses for services. Like if you want to configure your application server to contact your database, it's not fun to put an IP address in the configuration. And worse than that is changing that configuration based on which environment you're deploying that application. In a development environment, it's totally different from like sandbox, QA, production. So you need to change that every time. We're using Salt, that's true. It shouldn't be that hard to put pillars and grab mines and configure that. But it's easier to have something like Postgres database master, your domain, that you put in the configuration, and just forget about it. Just have a DNS to take care of that. And every time that you want to change where the database is, you just change your DNS. So those changes are consolidated in one place. So it's supposed to be easy. One more thing, actually, that's the most important reason why we did go with DNS. We didn't use things like service discovery with Zookeeper or console or etcd, name it. The reason that we didn't go with those, we didn't want to open up our old legacy applications and start doing some surgery on those to cram in those service discovery features. Actually, we have a service and we know that it has a memory leak, and we start that every day. Like we restart that application, a rolling restart on the servers that we have. It works, and no one wants to touch that thing, so just keep it as is. We just restart it every day. For the same reason, we don't want to change everything on the legacy machines. We just want to have a DNS to use that same application, for example, to point it to DNS. So we have a DNS, internal DNS, that resolves a made-up domain, auto.dot. We didn't want to create any collision. And we have bind servers that are managed by Salt. Why bind? Because everyone knows bind. In operations team, we didn't need to go teach anyone how to use bind instead of any other application that like half of the team knows how to use it, the other half doesn't. I know it's not the best name server, but it works. And we need to manage the etc resolve conf. We are mostly a Linux shop. We have some Windows servers. It is similar how we are managing those machines, but it's just more convenient to go through just one type of machine for the sake of this presentation. And let's say we have a legacy application that serves an API. We call it just API, and let's just do it. It's supposed to be simple. I put it in the Git, and in Git we have this thing. We need to set up the API, and we need to set up the DNS and set up the resolve conf. Actually, I have those already run. Let's take a look at the states before showing the results. We have the API. This is a simple one. It just sets up an Apache, creates a simple file inside that called test, so we can call it by get/test, and it just says hello world, as simple as that. So that's what we want to set up. Here's the result of setting that up. Salt minion, the minion name was minion. Status ls API installs Apache, sets up that test file, and makes sure that the Apache is running. FQDN of the machine was, the IP address of the machine was 172 and the rest of the story. We did the curl, looks good. Salt minion set val roles DNS. Next step, we want to add the DNS role to machine. I just set up a machine that has both roles. So what is the DNS state? Install bind, set up the configuration, and put the zone file in it. The configuration file is really simple. It's just mostly the default stuff. What we have in the zone file is, what we have extra in the zone in the configuration file is a reference to that zone file. And in the zone file, we have that. We have a test which is pointing to localhost. Actually, it's 127.0.1.1. We are going to change that to 0.0.1 later. But let's just test this part, and we'll take a look at the second part, the for loop after that. So set the roles. Looks good. Status ls DNS, installs the bind, configures the named.conf. It's mostly same as what it was. I just removed some of the security features and added some comments. I like that managed by Salt. Please do not edit on top of every file that's managed by Salt. And we added the zone at the end. And the zone file is a new file. Make sure the service is running. Okay. Now we run a dig. Query that bind that we installed locally to see if the test.auto.dot returns anything. It does. It looks good. It sends it responds with the IP that we have put in the bind. And we do a dig just like that without anything else. Just dig test.auto.dot. It doesn't return anything, because we have not pointed to localhost as a DNS name in our etc resolve conf. Our etc resolve conf is the one that's provided by Amazon DHCP. Ends with .0, .2, and it has a search ec2.internal. Okay, what are the roles of that minion? It's just DNS for now, and that's why this part, where's my mouse? That's why this part didn't do anything. Something like 3 years ago, when we started using Salt, or even before that, before Salt Mines, we had to send the commands to the master. When we wanted to query state of another minion, we needed to send a command to the master to be sent to another minion. Then the minion sends back the results, and master sends back the result to the minion that's executing the state. But instead of doing that, we can just cache it using mines. So we have a mine of IP addresses. In order to have that, we need to add it to mine functions, pillar or config, and every interval, which is by default 5 minutes or something, a minion will report back result of the functions that you asked it to run to the Salt Master. Salt Master will cache it and sends it to minions. It will be cached and it will be really fast. By the way, how many of you have been using Salt for more than 3 years? More than 2 years? Good. So this part, since we have not set the API role on any machine, it doesn't return anything. The for loop doesn't do anything. But where is that? Okay. But we also need to manage the resolve conf. So the test didn't even, we couldn't resolve test.auto.dot yet. We need to also manage resolve conf. We have another state that simply does that. It just iterates over machines that have the role DNS, puts the IP address in front of name server. As simple as that. When we run it, the minion had the DNS role, so that's the result. It just put the name server, then the IP address of the same machine in front of it. So when we run the dig command again, it runs properly. So we can resolve test.auto.dot. Let's add the API to our DNS. We just set the role to be both DNS and API, or we set the role API on another machine and refresh grains and grain cache and mine. And when we run the DNS state, the API line is added here. When we do the dig, API.auto.dot, it returns properly. Nice. Instead of doing that dig every time, I've just put it in a test state called test. It just manages that file. This is the MD5 of Hello World. It just tries to grab the file from there, which means it needs to resolve API.auto.dot. So let's run that state. We run state SLS test, and it fails. What happened? So the problem is the way that libc works is when you run your application, when libc needs to resolve something, it goes and reads etc resolve conf and populates the list of name servers in the memory. And every time that you want to resolve something, it just uses that. When we have started Salt and we ran the test, or we ran anything that needed to go to internet or resolve something, libc read that and had that name server list in memory. So when we changed etc resolve conf, the running daemon doesn't know about it, so it's not going to go grab the new name server from etc resolve conf. We need to somehow tell the libc library to go and reinitialize itself. In order to do that, we are going to use a module. You can either run this Python snippet, or you can use this one, resource init. The thing is, since Salt lazy loads those modules, you cannot just add that module and restart, or something like reload the modules. You need to run a function from that module to make Salt go and read that file and execute it. So if you even put a return true here, and in your virtual you really do the reload thing, it will also work. But the virtual is not going to be run until you run a function from that. So let's actually do it. In name resolution. I first used a more simple approach, just restarting Salt Minion. It works. libc is going to be reinitialized, and in order to restart Salt Minion with Salt, you cannot do the Salt Minion name service to restart Salt Minion, because while the job or task is running, the service is the daemon is going to be killed, which means it cannot return the result. Even if it's successful, your CLI is going to hang there waiting for the result. You will have a definite and indefinite running task hanging around because it cannot return the result. But what we can do is scheduling a restart. You can do the same thing in Windows. So what we do is, I think it's obvious. I'm not going to go and read that. It's just a service restart. It's a long command to make sure it's stopped before restarting it. Because if you run the stop and start right after, it might not be stopped completely. So when it starts, it tries to start, the port is already in use, it cannot start. It will cause kind of disaster if you don't have a stage access. The thing is, if you restart, then test next time, it will be fine. But if you restart, but you have a test just right after, it will not work because this thing can only work after the restart. So if you have long-running tasks, this restart is not going to be useful. That's why we wrote that module. But on the other hand, if you have that module run, here we need to make sure that module is loaded and we run that. If you run that module, next time that you run the test state, it will not work properly. Let's take a look. We run the name resolution again, it changes that. We reload the sync module. We do the sync module to reload the helper module that we just wrote. Then we restart the minion, or actually we rather schedule the restart. And when we run that test, it actually works. But if we don't either of them, it would not work properly. I mean, either restart or reloading. If we don't do the restart, we just reload. In the worker that we just started, it will work fine. Next time that we run it, it will not work properly because it is a child of long-running parent. So it's going to inherit the libc memory of the parent that was initialized before our changes. So it's not going to work properly. If you run just stop start or you run the restart, sometimes it doesn't work because of long stop. So what we do is we stop it, we wait a second or two, we kill it. At this time, there shouldn't be anything to be killed, but we just make sure that there's nothing running. Then instead of doing a service start, we do a service restart. So if there's still anything running, restart it. The thing is, we had problems with a simple restart or a simple stop start. So we are making sure that it's not going to happen again. In a normal situation, if your Salt Minion service works in a timely manner and stops and starts pretty fast, you're not going to have any problem with a simple no-hop, sleep for a few seconds, then do a restart. That should work fine.
Is a stop, start, or restart required? I thought you mentioned that there was another way you could just load the module.
Oh, we are going to do both of them.
Okay.
If we just load the module and we do this test, it works fine. But next time, like next state that we run or next module execution that we run, it's not going to work because we reloaded that in the child process that's running the state. But the parent process is the old one. So when we run a new task or we schedule a new job, it's going to be forked off the old parent, which has the old name resolution configuration. So we need to do both to be able to run the rest of our state in the current session, current task, and do the next one. So, there is no second atom without a third. And why is actually, that's a direct translation from French, jamais deux sans trois, and I will explain why. There was a problem that I guess most of you didn't notice. When we updated the zone file, something didn't happen, which is the serial was not updated. So we either can have a complicated, complex way of calculating that serial, or we can just easily use time, epoch, in seconds. It always goes up, and we just truncate it if we need to, if it's too long, and we just use that. So let's do it. That one's not that hard. We cannot use time or epoch in Jinja, so we need another function for that. We just simply do that, or actually it's not the correct branch. This one would be better. Yes. So we just return time.time, time in epoch. As simple as that. In our DNS configuration, we just put it here. Let's run it. So we just changed the test to be 127.0.0.1. Before doing that change, it doesn't change the serial, but when we did that change, it also changes the serial. But there's another problem. We did change the serial, but we shouldn't have, because nothing else has changed. So every time, you see, this is one run, and this is another execution, it just changes that again, because it runs that function, it gets another value, it updates the file. As simple as that.
Wasn't it also smaller? It was a smaller number.
Shouldn't be.
I know eventually it'll work itself out, but
This one is 650. This one is 637. Oh, the one on top. The one was the hard-coded value that I've put in the file before calling that function. I wrote that config file 2016-04-20, and that was the first iteration.
Wouldn't it only work when you increment it?
right. So it wouldn't detect the changes quickly. It wouldn't check it as you went smaller. It would detect it quickly.
True. So this thing wouldn't work. True.
It'll eventually figure it out.
Yeah, that's true. You know, this one is faulty. It's not going to work. But the first time that we really put it out in our environment should be a number that's going to always go up. So this version that I put the serial number manually, that was a hard-coded value, I shouldn't have 2 at the beginning. I should have like 1. Or when I wrote that function, I should have like added 1 million, 1 billion, I don't know, a big number to that to make it bigger every time. I just wanted to see how it's going to behave. Since I don't have any clients actually that are querying that bind, it doesn't matter. It just goes down. Okay, I see it changes. That's fine. And next time that I run it, it changes and it goes up. But the thing is, it just shouldn't change because I didn't have any other changes. So the thing that I came up with the first time was putting it in a grain. and just changing it when it's needed. So in SLS, I just put it in grain, and I just use it when it's needed. Let's test that. Let's test that one. Let's see how it goes. Even worse. It says Jinja variable dictionary object has no attribute DNS sequence. But here, it's prerequisite. Am I right? Yes, it is a prerequisite. This state is a prerequisite of the file managed. So when we go to the file managed, it sees that it needs to set that, so it should set that. And does anyone have any idea what's happening?
When you set the grain, your Jinja rendering runs first.
Why is that? This one is a prerequisite of that one. Like, this one should run before how prerequisite works is, for example, you want to stop you want to update your application, which is running on Apache. So you have a prerequisite saying stop the application before updating the application.
Jinja always runs first. What's a solid helper.dns sequence?
Where this one? This is the function that I just showed you. It's just return time.time.
But it renders before the state runs.
The thing is, since we have a prerequisite, it needs to evaluate.
It always runs first. It doesn't depend on, you finish all the Jinja and then you start working on the
Yeah, not always. Not always. It depends. True. But the problem here is, since it's a prerequisite, it needs to evaluate the second state with a test argument, then goes back to the first one. And it's handy when we change it, because if it compiles that Jinja every time before the first prerequisite, it's not going to work properly. Like if it just blindly does that, if it doesn't consider the prerequisite. The thing is, it passes the test to the second one, which is a prerequisite of the first one, runs that, compiles a template to see if it needs to run the first state. Then if it does, it runs the first state and runs the second one after one. So we can just have a default, which I just did like this, or you can just 1 or whatever value and it should work. Like this. And the default value doesn't matter because it's going to be evaluated before setting the grain the first time, and it's going to be overridden by the first execution. And after that, if you run it again, the state DNS, it would just say that everything is fine. And when you change the value of 127.0.0.1, when you change that name d-auto.dot zone, it sees that this thing has changed, so it needs to change the serial number and the value. If you do it again, it won't change it. I'm not going to go over that. Like, it's a bunch of tests. If you change it, it changed. If you don't change it, it doesn't. So there's also a 4. 3 is not always the charm. What about repo.saltstack.com? We have set up that internal DNS in our resolve conf, and that internal DNS is serving auto.dot. What about the other things? For example, if you want to deploy something from a repository that's coming from the internet. Actually, the ones that are coming from the internet are covered because we are using the default bind configuration that's pointing to the internet for the zones that it's not serving. But what about the ones that are served, that are given to us by the DHCP For example, the .0.2 that we saw earlier in the configuration of that AWS EC2 instance, or the ones that are provided by CloudStack. And the ones that are provided by the DHCP are really handy when you're using applications that are rely on reverse resolve of host names. For example, if you are deploying a Cloudera stack, in order to connect applications together, components together, you need everything to be able to resolve everyone else's name, host name, and do the reverse lookup of the IP address. So we also need those. So first thing that comes to mind is putting it in resolve-conf, putting just the what we get from DHCP, putting it in resolve-conf. We have that IP address of the bind that's serving the local stuff and the IP address of the the one that's provided by the DHCP, both in resolve-conf, but it doesn't work because the way libc works is it looks at the first one, and if it times out, it goes to the second one. But when the internal DNS is queried about, let's say, EC2 internal, it responds with, there is no such a thing. And libc just stops there. It says there is no such a thing. It doesn't go to the next one. It's not a timeout. Next thing, we can put it in forwarders. So we can forward those queries from named with the internal DNS that we have to the ones that provided by the DHCP. I'm just going to go over pretty fast over those, short on time. You can see how it's done in the GitHub repository if you would like. So in order to do that, again, the first thing that comes into mind was the ifconfig, the ifcfg startup scripts. But the problem with that is we don't have access to the DHCP provided DNS in those files. Unless we know what it is beforehand and we hard code it, we cannot do it. So what we did was putting them in DHCP hooks. So every time that DHCP runs, gets to the point that it knows about DNS, it can add our DNS before the list of DNS that it got from DHCP and then construct resolve-conf. The problem with that was we were configuring resolve-conf with both the name resolution state and the forwarders, the DHCP. So we needed to consolidate those in something that just manages the DHCP hook. We took it out of that and we just included as a include statement in the DNS state. And after that, we felt pretty good about it. It was working. We said, like, we have multiple machines that are serving that API, so we can deploy without a downtime. We get round-robin behavior of the DNS out of the box. But the problem is it's cached. It's DNS. It's cached everywhere. So we needed to use a load balancer. In order to use a load balancer, we said we are going to use NetScaler in our non-AWS environments and ELBs in AWS environments. But the thing is, we have so many endpoints or ELBs or virtual IPs that if we wanted to do that, it would have cost us a few $100,000 a year. So we're sticking with the Citrix NetScaler everywhere. But the easier one is using ELB and Route 53. We need a Route 53. We can have public, private zones. We put those ELBs in. Should be easy. We just create the Route 53 zone. We create the ELB. We can do those by Salt. We can do them manually. And for the Route 53, it's a one-time thing. We can do it manually fine. But for the ELBs, we need that for every service. So it should be formulated. And we add those ELBs into those zones and add machines to those ELBs. So we have one instance running, for example, here, and that's the instance. For the Citrix NetScaler, we had more flexibility, and it was much more complex. But we are not done. The problem is there are lots of issues. By issue, I mean missing features, behaviors that are not expected, or real bugs in Salt that are affecting mine. For example, if you have created a machine and it has not reported its mine back to the Salt master, it will show up in every mine get. What I mean is, if you have a machine and you define the role to be database, and you do mine get on it, and you ask it to return back IP of the machines that have the role of API, that database will also show up in that result, which is bad, which your application is trying to contact that in the backend and it will fail. Thank you very much. Sorry about the rush in the end, but the code is in GitHub. You can look at the code and how we are done it. At the beginning, it looked really simple, but like SMTP, it's called Simple Transfer May Protocol. It's not simple. The SNMP also, simple. LDAP, it's not lightweight. Same thing. In that book says, let's start simple, but if you have legacy and you're stuck with DNS, it's not simple to do it right. Any questions?
So you put DNS on every single server?
No. It's just one DNS, and it reports back the mine. So every other machine grabs that mine and knows where it should go to query for the DNS. Just for the test purposes, I just put it on the same machine.